Hello everyone, it is time to do lesson 10-7, which is area of circles, and we're going to do areas of sectors of circles and area of segments of circles. So first thing I need y'all to know is I normally do these videos in the morning before my kids and my animals get up, but this is the afternoon today, and so if you are interrupted by this guy, or if we are interrupted by this guy, I'm very sorry. Hopefully we'll do okay. All right, so you can put a date on there and your name on there if you want. This is a process for finding the area of a sector, but we're going to start off finding the area of a circle. So the formula for the area of a circle, area is pi times radius squared. So this answers the question, why did we do all that circle vocabulary yesterday in the middle of this area chapter? It's because we're doing areas of circles and areas of parts of circles. So here's the formula, and to evaluate this formula, we need the radius. This segment right here, from one side of the circle to the other, this is the diameter. We need radius. The radius is 9, and then we plug in 9 right there. So this is pi times 9 squared. Okay, when one of the biggest mistakes with circle problems is people will punch this into the calculator like this. They'll do pi times 9, and then they'll square that. And that is not the right answer, because you're not squaring that whole product. You're only squaring the 9. So remember, order of operations, you have to do powers, exponents, before you multiply. So this is pi times 81, and you are allowed to just leave the answer 81 pi, especially since it didn't say to use anything for pi, or if it didn't say to round, then that's especially true, that you just leave it 81 pi, and it's inches squared. If they ask you to round it, this is when you grab the calculator and you just punch in 81 pi, calculators have the pi symbol, and it'll evaluate it for you, 254.5 roughly. They usually tell you where to round to. So you could punch that in a calculator at that stage. So I'm going to write that down. Or what did I say it was? 254. I forgot already. 81 pi. 254.5 inches squared. It all depends on if they ask you to round or not. Okay, so you have some questions like that in the homework where you're just using this area formula to find the area of a circle. If they give you the radius, then obviously you wouldn't have to do this halving the diameter part to get the radius. So okay, sorry, my dog escaped. All right, so that's question number 1. Now the rest of these notes are about finding the area of a sector. So here's the gist, okay? A sector is just part of a circle. So if we had this entire area, that's the area of the whole circle. But if we wanted an area of a sector like this, well, that's just part of the area of the whole circle. We just have to figure out what part it is based on the measurements. Okay, so I'll come back to this in a minute. These are the directions, but this is what the question would look like. They want us to find the area of this shaded, remember sector means slice, so this shaded slice. Now in the book it's going to be kind of colored in. I just couldn't color in using the program I was using to write these notes. So it really is going to look more like that. And they want the area of just that part. So here's the process. You find the area of the entire circle. That's step 1. You find the area of this entire circle. And obviously the answer is going to be less than that, because we want the area of just this small slice. Then you find out what fraction of the whole circle this slice is. And the way you do that is you take the measure of the angle, divide by the measure of the entire circle, which is 360 degrees. So in this case, it would be 30 degrees over 360 degrees. And then you reduce that, and that's what fraction of the circle this sector or slice is. And then you just multiply. You multiply that fraction times that whole area. All right, so let's do one. All right, step one. We're gonna find the area of the entire circle. Area is pi times the radius squared. Notice how I write the formula. Always write the formula. That's pi times, this time they're giving us the radius. So 10 squared, that is 100 pi. Now always remember, always think after each step, what did I just find? Because sometimes people do one thing and they're like, oh, I'm done, I have the answer. But that is the entire circle. So if you need to, write it down, 100 pi is the whole circle. Okay, so that's step one. Step two, obviously if that's the whole circle, this area is going to be much less than that. We just have to find out how much of the circle this slice is. So this slice is 30 degrees out of 360 degrees. And if you want to reduce that, that reduces to 3 over 36, and 3 over 36 reduces to 1/12. If you are terrible at reducing fractions, your calculator reduces fractions for you. 30, ABC 360, and it reduces it to 1/12. So that is 1/12 of the circle. And then you just have to find 1/12 of 100. Now this answer is ugly because 1/12 of 100 is an ugly answer, but it's a 1/12 of 100 pi. So see, we're multiplying. Of means multiply. So 1/12 of 100 pi is 1/12 times 100 pi. I would probably write that as, let's see, 4 goes into both, so maybe 25/3 pi centimeters squared. If you want to write it as a decimal, you can. 1/12 times 100 is 8 1/3 pi, or you can even do 1/12 times 100 pi, and it gives you this answer. So it all depends on how they want the answer. So just read the directions about whether they want it rounded or how they want this answer written. I was gonna say something about that and lost my train of thought. I'll think of it. Okay, so 3-step process. You find the area of the entire thing. You find out what fraction it is. In this case, it's 1/12. Oh, I remembered my train of thought. You don't even have to reduce. If you multiply 30 3/60ths times 100 pi, it's going to give you 8 1/3 pi. It's going to give you that same answer. So even unreduced to 1/12 will work. So you find the area of the entire circle, you find out what fraction it is, and then you multiply. So example 3. So this is the shaded part. Now some of you are pretty good with fractions, especially those lessons when you first learned fractions when you were little, and the teachers would draw like a pie chart looking thing, and they would ask this question, how much of the circle is shaded, like that. So if you remember those kind of questions, you'll be able to tell easily that, or quickly, that this is 3/4 of the circle. But here's another way to think about this. This is 90. This shaded part is the rest of the 360. So if you take 360 and take out 90, the rest of this is 270. So 3-step process. Find the area, pi times the radius squared. That's pi times 5 squared. So in class, I would stop every now and then and have you guys do one. So just remember, you can always do that with these videos. You can stop the video, do part of the problem, then press play. So you don't have to just sit and watch me teach the whole thing like that. You can stop it and try your problems. So plugging that in, you get 25 pi. Remember what that answer is. That answer is the entire circle, as if the whole thing was colored in. The fraction that's shaded is 270 out of 360. You can leave it unreduced. It'll still work if you leave it unreduced. or you can reduce it, and that reduces to 3/4. And then you do 3/4 of 25 pi. 3/4 of 25 pi. And that gives you, this one's ugly too, because 4 doesn't go into 25. 3 times 25 is 75. The 4 is still on the bottom. So, and if you don't like that, you can do it in a calculator. You can do 3/4 times 75, and it gives you 56 1/4. That's the same thing as 75/4, because if you change that mixed number to a fraction, oh, hold on, I did something wrong. 3/4 times 25. 18 3/4. And if you don't like that answer, you can write it like that. So your calculator can do all that stuff. All those fraction keys can do that. Anyway, don't forget the pi. So 3/4 times 25 is 75/4, and there's still a pi there. Meters squared. So remember what all these answers mean so that you know when you're done. This is the whole circle. This is what fraction is shaded. This is the answer. This is the area of that shaded part. Okay, this would be a great time, a great place to stop this video and do this problem, and then press play. So here's our shaded part. We're gonna do 3-step process, find the area. Area is pi times the radius squared. The radius is 6. Pi times 6 squared. That is 36 pi. Inches squared. Remember, that's the entire circle. And then we write down what fraction is shaded. 120 out of 360. 120 3/60ths. You can leave it unreduced if you want. You can reduce it to 1/3 if you want. 120 over 360 reduces to 1/3. That's what fraction of the circle is shaded. And then you do 1/3 of 36 pi. This one comes out nice. 1/3, 1/3 of 36. Of just means times. So you get 12 pi. If you want that answer as a decimal, then you can type in 1/3 of 12, not just 12, but 12 pi. And that'll give you this answer as a decimal. Hold on, I did that wrong. 1/3 of 36 pi, sorry. 1/3 of 36 pi. There it is. So that's the same answer as 12 pi. It all depends on whether you want your answer left in pi, that'd be 12 pi, or if you want to type pi into the calculator and round your answer and give your answer as a decimal. 12 pi inches squared. Okay, there's one more problem to do. If you are in my first period class and my fourth period class, you can stop listening right now, because you guys are going to do area of sectors, but you guys aren't going to be asked to do areas of segments. So first and fourth, y'all have a great day. Now, unless you want to stick around and learn something else, that's up to you. Okay, 6th and 7th, we're going to find the area of segments of circles. Okay, so a sector, remember, is a slice like this. A segment is a piece of the circle like that. Okay, so here's what you do. You find the area of the sector, which is what we just did that 3-step process to do. So this right here, find the area of the sector. Remember, that is a 3-step process. You find the area of the whole circle, you find what fraction it is, and you multiply. So first you gotta do that. And then you find the area of this triangle. Now I wrote down this little shortcut formula. This is the whole reason why we learned that little bonus formula at the end of area of one of the polygon sections, because problems like this, using that formula will make this real quick. And then you take the whole slice and you subtract out that triangle, and that's going to leave this segment. This is called a segment of a circle. Now, for this particular problem, we could find the area of this triangle using special right triangles. But that will only happen if you've got certain angles here, okay? So I'll show you this both ways. Now, this is kind of a long process. So first thing we're gonna do, we're gonna do the 3-step process for finding the area of this entire slice. So I'm gonna put sector. Remember, that means slice. So the whole circle is pi times 6 squared, which is 36 pi. And then the part of the circle that slice is 120 3/60. That's 1/3. And then 1/3 of 36 pi, 1/3 of 36 pi is 12 pi. So this should sound familiar because that's example 4, basically. That's what we did in example 4. Okay, so remember, you need to know what these numbers mean. This is the whole circle. This is what fraction that slice is. And this is the slice. This is the sector. So this is the area of this entire slice right here, including the triangle. So we just need to take this entire slice right here, which is 12 pi, and we need to subtract out this triangle, and that's going to leave that segment. So we need to find the area of the triangle. Okay, this is the part of the problem that we can do 2 different ways. I'm going to do it this way first. So 1/2 times b times c times sine of a. B and c are the 2 sides, and a is the angle. And since this is in a circle, and this is a radius, well, this is also a radius, so it is 6. And that's how I know we have side angle side. And these radii will always be the same. So you're always going to have these same numbers to have side angle side. So this will be 6 times 6, and angle A is 120. And this will give you the area of the triangle. So 1/2 times 6 times 6 times sine of 120. It gives you this answer right here, 15.588. Let's put one more. Okay, that's the area of the triangle. Now, another way to get the area of the triangle. You can do 1/2. Hold on, let me think. Oh yeah, that's gonna take some work. 1/2 base times height. Okay, I'm gonna turn this. This would be the height that I need. And the reason I drew it there is because I'm going to need a right triangle to be able to do this right triangle work. And so that triangle is a 60-degree angle there. And this radius is 6, or this hypotenuse, radius of the circle, hypotenuse of the triangle. And in a 30, 60, 90 triangle, that is twice A. Let me put those labels on there. This is A. This is twice A. This is A radical 3. So if twice a is 6, then this value is 3. That's the height of the triangle. And this value is 3 radical 3. So the base of that white triangle right there is 3 radical 3 and another 3 radical 3. So 6 radical 3. And the height is 3. So 1/2 times 6 radical 3 times a height of 3. Half of 6 is 3, and 3 times 3 is 9. This is 9 radical 3. And if you punch that into your calculator, 9 radical 3, you get that same answer that we got with this formula. I think this was just so much work in light of how much work this whole problem is. That's just a lot to do. So that's the whole purpose of learning this little bonus triangle formula, is to make that right triangle work unnecessary, and it's just quick. Okay, so no matter how you do it, you've got to find the area of that triangle. So the last step is to subtract the area of the slice, the sector, minus the triangle, and that's going to leave you this segment. So sector minus triangle is 12 pi minus 9 radical 3, or 15.5885. Now, in my opinion, if this is already a decimal, then you might as well do that as a decimal and subtract and get one decimal answer. So 12 pi minus this 15.5885 gives you 22.1 roughly, so approximately 22.1 inches squared. There in our book, I think it leaves the answer like this. It would leave it 12 pi minus 9 radical 3.
Y'all give me a drink?
It would be 12 pi minus 9 radical 3. I think that's how the book leaves that answer. But I like this answer better. So here, you find the area of the sector, which is 3 steps. Those are like the problems we were doing on the front. You find the area of this triangle, and then you just subtract the sector, that slice, minus that triangle, and it gives you your final answer here. All right, so that is all there is to lesson 10.7. All right, y'all have a wonderful day today.